with something simple, or at least something we think is simple. Right? When you woke up this morning and the sunlight came through your window, you probably didn't stop and ask, what is that stuff? Really? Or did that? You just called it light and got on with your day. Rich part. We've been studying light for hundreds of years, and we still can't give a completely satisfying answer. Is it a wave? Well, yes, sometimes. Is it a particle? Yeah. Also, yes, which is very suspicious. Does it travel through empty space at the fastest speed possible? Absolutely. Does it behave in ways that completely defy our everyday intuition? Oh, all the time. So the question isn't just what is light? The real question is what kind of universe allows something like light to exist at all? Tonight, I'm not going to just give you definitions or formulas. I want to take you on a little journey. A journey where the deeper we look at light, the less obvious it becomes, and the more fascinating the universe reveals itself to be. With something simple, or at least something we think is simple. When you woke up this morning and sunlight came through your window, you probably didn't pause and wonder what it actually is. You didn't sit there thinking, what exactly is this thing that lets me see the world? You just accepted it like we all do. We call it light. We flip a switch and the room brightens. But if you slow down for just a moment and really ask the question, you'll begin to notice something strange. Light is everywhere. It defines how we experience reality. There's no color, no visible motion, no sense of distance or shape. Everything we see depends on it. And yet the moment we try to pin it down, to describe what it actually is, things start to get slippery. It seems easy. Light travels in straight lines, right? That's why shadows form the way they do. That's why you can shine a flashlight across a room and see exactly where it goes. Actually, people once thought of light as tiny particles, little bullets flying through space. But then something unexpected happened. Scientists began to perform experiments, and light started behaving in ways those little bullets simply couldn't explain. It could bend around corners. Now, it could spread out. It could interfere with itself, creating patterns of bright and dark stripes as if it were a wave moving through water. So now we say, light must be a wave. Problem solved. Not quite, because when we look more closely, when we design experiments carefully enough, light suddenly goes back to behaving like particles again. Particles, but discrete packets of energy, we call photons. And these photons don't split up neatly like waves should. They arrive in chunks, countable, individual events. So now we're stuck with something that is, in a very real sense, both a wave and a particle. Not one or the other, depending on our mood, but something deeper that doesn't fit neatly into either category. That makes you uncomfortable. Good, it should, because it means our everyday intuition isn't built to handle the way nature actually works. And it gets even stranger. Light doesn't need a medium to travel through. Sound needs air. Water waves need water. But light can move through empty space, through the vacuum between stars, without losing its identity. It's a very specific speed, always the same, no matter how fast you're moving or where you're observing it from. 100 лет. This speed isn't just a property of light. It's woven into the structure of the universe itself. But the more we study light, the more we realize it's not just something in the universe. It's something that helps define how the universe behaves. Them themselves seem to adjust to keep the speed of light constant. That's just unusual. That's telling us we might be asking the wrong kind of question when we say, what is light? Because maybe light isn't a thing in the way a rock is a thing. I mean, you can hold or isolate in a simple way. Maybe it's a manifestation of deeper rules. Rules that govern energy, motion, and information at the most fundamental level. So when we ask, What is light, really? Well, something we see every day. We're stepping into a question that challenges the way we think about reality itself, to confront the possibility that the universe is far more subtle, far more surprising, and far less intuitive than it first appears. Now, let's take this a little further. This getting comfortable with light, it does something that completely upsets that comfort. Imagine you're in a completely dark room, no windows, no lamps, nothing. And for just a brief instant, a single tiny flash appears. Not a beam, not a continuous glow, just one small, isolated, the smallest unit of light we can detect. Now, here's the question. Where exactly was that photon before you saw it? You might be tempted to say it traveled along a neat straight path from its source to your eye, like a tiny marble rolling across the floor. That's how we imagine things moving in everyday life. But when we actually test this idea, when we set up experiments sensitive enough to track what's going on, light refuses to cooperate with that picture. It behaves as if it doesn't take just one path, but many paths, all at once. Not one or the other, not switching between them, all of them. Out of all those possibilities, what we finally observe is a single definite outcome. One flash, one detection, one event. That's if nature explores every possible way light could travel, and then quietly settles on a result that reflects all those possibilities combined. Now, that's not the kind of behavior we're used to. Or it doesn't tie every possible trajectory through the air before landing in your head. It follows a single path, predictable, clear, understandable. Light doesn't play by those rules. If you design an experiment carefully, you can force light into situations where it seems to decide how to behave based on how you choose to observe it. If you look for wave-like behavior, you find it. Things up to detect particles, you find those instead. It's not that light changes its mind in a human sense. It's that our classical categories simply don't capture what it is doing. We're faced with a deeper issue. The problem isn't just understanding light. It's understanding the limits of our own thinking, our intuition from everyday experiences, poles, waves, objects, motion. But light operates at a scale where those familiar ideas begin to break down. And this isn't just philosophical curiosity. These strange properties of light are the foundation of modern physics. Technologies like lasers, fiber optics, and even the screens you're looking at depend on this dual nature. They work precisely because light doesn't behave the way we expect. Not up to us. Light doesn't experience time the way we do. The best theories, from the perspective of a photon, if such a perspective could even be said to exist, the journey from its source to its destination happens instantly. No passage of time, no sense of distance. What we measure as millions of years across space could in some sense be nothing at all to the light itself. That idea stretches the imagination in a way that's hard to fully grasp. Light teaches that light isn't just moving through space and time. It's revealing something about how space and time themselves are structured. And so we come back to the original question. But now it feels very different. We're no longer asking about something simple or familiar. We're asking about something that sits right at the boundary between what we can absorb and what we can truly understand. Every time we try to describe light in simple terms, it slips through those descriptions. Every time we think we've captured its nature, it shows us another side that doesn't quite fit. And yet, despite all this mystery, it remains one of the most precisely studied and consistently predictable phenomena in science, obeying mathematical rules with extraordinary accuracy while still defying our intuition at every turn. And now, it is strange enough, we arrive at a point where light begins to blur the line between reality and information. Because when you really look closely, what light does is not just travel, it carries information. Every ray of light reaching your eyes right now is telling you something. The color of an object, its texture, its motion, its distance, all of that is encoded in light. In a real sense, you are not directly seeing the world itself. You are interpreting messages delivered by light. Now that might sound ordinary at first, but think about what it implies. You see depends on light carrying information that your entire visual experience is a kind of reconstruction. Your brain is constantly taking signals, tiny packets of energy arriving from all directions, and building a picture of reality from them. And the question becomes, is light just revealing the world, or is it actively shaping the way the world appears to us? Because light doesn't simply bounce off objects like a perfect messenger, yet it interacts. It gets absorbed, re-emitted, scattered, stretched, compressed. It changes depending on what it encounters. And those changes are exactly what allow us to see detail. But they also mean that what we perceive is already filtered through layers of interaction. Color, for example. You might look at something and say, that's red. But what does that actually mean? It means that the object is absorbing certain wavelengths of light and reflecting others. This isn't a property sitting inside the object like a label. It's the result of how light and matter interact, combined with how your eyes and brain interpret interaction. It's as simple as color turned out to be a collaboration between the external world and the light that reaches you. And it doesn't stop there. Light also allows us to look far beyond our immediate surroundings. When we observe distant stars and galaxies, we're not seeing them as they are now. We're seeing light that has traveled for years, sometimes millions or billions of years before reaching us. That light carries a history, a record of what those objects were like when the light began its journey. In that sense, light becomes a kind of time machine. It connects us to the past, allowing us to study events that happened long before we existed. But it also means that what we call seeing is never truly about the present. It's always about interpreting signals from the past. And here's where it becomes even more subtle. We find the limits of light, define the limits of what we can know. There are regions of the universe so distant that their light hasn't had enough time to reach us yet. No matter how powerful our instruments become, we cannot absorb what lies beyond that boundary, not because it doesn't exist, but because the information simply hasn't arrived. It doesn't just show us the universe. It sets the horizon of our knowledge. And at the smallest scales, light plays an equally profound role. It interacts with atoms and electrons, determining how matter absorbs and emits energy. Atoms, the stability of molecules, even the processes that make life possible, are all deeply connected to the behavior of light at the quantum level. When we ask, what is light? Really, we're no longer asking about a single phenomenon. We're asking about something that connects vision, energy, space, time, and information into one unified story. It's not just something that illuminates objects in a room. It's something that defines how we perceive reality, how we measure the universe, and how we understand the laws that govern everything around us. And the more closely we examine it, the more it seems that life is not just a part of the universe, but one of the most fundamental ways the universe expresses itself. And at this point, we're forced to confront a rather uncomfortable idea. Maybe the problem isn't that light is too complicated. Maybe it's that our expectations are too simple. We tend to believe that everything in the universe should fit into clear categories. A thing should either be this or that, here or there, moving or not moving. That's how our everyday experience works. So we naturally expect the deeper layers of reality to follow the same rules. But light keeps refusing to cooperate with those expectations, almost as if it's quietly reminding us that nature is under no obligation to make sense in ways that feel comfortable to us. The idea of location. If you ask where an object is, you expect a definite answer. It's on the table, in your hand, across the room. But with light, that certainty begins to fade. Before it's detected, a photon doesn't sit neatly in one place waiting to be found. Instead, it's described by a range of possibility, a spread of where it could be. Only when an interaction occurs do we get a specific outcome, a definite position. Now, that doesn't mean light is hiding somewhere unknown. It means the concept of a single, well defined position might not even apply in the way we think it does. What exists instead is a kind of probability, a set of potential outcomes, each with its own likelihood. What I observed before that we're not uncovering a pre-existing answer so much as participating in the process that produces one. The idea challenges something very deep in how we think about reality. We like to imagine that things have definite properties, whether we look at them or not. That the moon is there even when no one is watching. That objects have positions and motions independent of observation. And for large, everyday things, that works perfectly well. But at the level where light operates, the story becomes more subtle. That reality disappears when we're not looking. It's that the way reality is defined becomes inseparable from the interactions that reveal it. Light doesn't just passively exist, it's constantly involved in exchanges of energy and information. Every time it interacts with something, an electron, an atom, your eye, it creates an event. And that event is what we ultimately call a measurement. And this leads to another curious point that is involved in every act of seeing, then every observation we make is also an interaction. We are never completely separate from the system we're observing. The act of measuring something with light, say, shining it on an object to determine its position, inevitably changes that object in some way. Very small scales, that change isn't negligible, it's fundamental. So now the idea of a perfectly objective, detached observation begins to break down. Not because science is unreliable, but because the universe itself doesn't seem to operate in a way that allows complete separation between observer and observed. And still, despite all this, light behaves consistency. The probabilities follow precise mathematical patterns. The predictions obey strict rules. It's not chaos, it's a different kind of order. One that doesn't align with our everyday intuition, but is nonetheless deeply structured. This is what makes light so fascinating. It sits right at the intersection of certainty and uncertainty. On one hand, we can predict its behavior with incredible accuracy using equations. On the other hand, the meaning of those predictions, what they say about reality itself, remains open to interpretation. So when we keep asking, what is light, really, we start to realize that we're also asking something else. We're asking how far our concepts can stretch before they start being useful. The universe is built from things we can easily picture, or from principles that only make sense through mathematics and experiment. And perhaps most intriguingly, asking whether understanding light will eventually lead us to a deeper, more unified picture of reality, or whether it will continue to stand as a reminder that some aspects of the universe resist being reduced to simple, familiar ideas.